Hey guys, this is Miss Wendt, and this should be the first page of a packet. If you don't have it, you can go ahead and pause the video and go find it somewhere. And on the front page here, I've underlined a few things. This reading should be mostly review, but it's always good to practice reading and to do this. So take a minute. You might want to pause the video. You can kind of underline or circle the stuff I did and read this over. So go ahead and do that. And scroll down a little bit here. So this reading just reviews the difference between protons, neutrons, and electrons. We have this word here called an isotope, which we had talked about. So those are atoms that just have a different mass. So they act the same way and they have the same protons and electrons. They just have more or less neutrons. Okay, and electrons are very tiny there. So this is just kind of a review, get your brain going today. So the questions at the bottom, I'm going to go through them pretty quick. So you may have to pause the video and fill stuff in if you need to, and that's fine. So the three major subatomic particles. So subatomic, that's going to mean smaller than an atom. So the three particles that make up an atom, proton, neutron, and electron. Now, number 2 is talking about this element here, U-235. If you look on the periodic table, U stands for uranium. And that element is pretty important in the world. Uranium is used for nuclear power plants, which a lot of countries use to get most of their electricity energy. It's also used for nuclear weapons and other not so nice things too. So governments around the world keep pretty close tabs on who has this. And we have two different isotopes here. This uranium atom has a mass of 235. This uranium atom has a mass of 238. Okay, so I can tell you one of them is radioactive and will break apart and is used for all these power plants and stuff, and one is not. Okay, it says the numbers next to the chemical symbol for uranium is the mass numbers. So if uranium's atomic number is 92, and you can look that up on the periodic table, uranium is 92, it's on the bottom row. How many neutrons does U-235 have? Okay, well, to find neutrons of any atom, you take the mass of 235, and if you subtract the protons, you're going to get the neutrons there. So you can go ahead and do the math and figure that guy out. So 235 minus 92. And do the same step here for uranium-238. So the mass of 238 minus 92 protons will give you how many neutrons you have. So do the math, figure those guys out. Number 3, I put a big star by this because this is a big deal question. What would have more of an effect on the mass of aluminum atom? Removing 10 electrons or 1 neutron? And my answer, I said 1 neutron because it has more mass. Okay, electrons are so tiny we don't consider them to have mass. Okay, so it's kind of like saying what's going to have more of an effect, taking out 10 little specks of dirt and dust, or taking 1 tire off your car. Well, the 1 tire is going to have much more mass than 10 specks of dust. So the 1 tire has more mass. Number 4 and 5. Nope, I'm sorry, just number 4. It's kind of 2 parts to this. It says, what do you call a germanium atom if you remove 2 protons? Well, if I look on the periodic table at how many protons germanium has, and if I subtract 2, I have a different kind of atom. Okay, and I would go 2 spaces down on the periodic table, and zinc is the atom that would be right there. Okay. However, if I take neutrons away, neutrons does not change what kind of atom it is. Only protons do that. So if I take neutrons off, it's still a germanium atom, but now I can call it an isotope because it has a different mass than the normal germanium one we started with. Okay. Number 5. You can go ahead and finish that guy up. And when you're ready, go ahead and turn the page. All right, so the next page looks something like this. It says identifying patterns on the periodic table. Kind of bring that down a touch for us. So directions. Use the periodic table to identify these elements. Give the atomic symbol, mass, number of electrons, and valence electrons. We're not going to worry about all of that. What I would like you to do is to draw the electrons on each of these guys. Okay? So let me get my pen going here again. So we kind of learned some rules for drawing atoms. And I know that the electrons, a certain number fits at each energy level, and we have a certain number of different, electrons depending on the atom. So this first atom here, the very first thing on the periodic table, this is going to be atomic number 1. Over here, number 2, this is helium. And number 3, 4, 5, 6, 7, 8, 9, 10, and so forth. And for some reason, the computer, don't do that. This guy up here, we're going to get rid of him. And we're going to turn that back into a number 1. All right, so here's our atomic numbers. And the atomic number for a regular atom is also going to match the electrons. So I know this hydrogen up here has got 1 electron. It also has 1 proton and 0 neutrons if you really want to fill it in. Hydrogen is symbol is H. The mass of hydrogen, 1 plus 0 would be 1. It has 1 electron, and we haven't learned valence electron yet. We're not going to worry about filling all that in for all the atoms, though, because of time. All right, so this guy had 1 electron. Over here, atomic number 2 has 2. They both fit in that first energy level. Then we start a new row. Okay, this guy has 3. I know the first 2 electrons have to go in this first energy level. The third electron goes in the outside. This guy has 4. 2 in the first, 2 in the second. This guy has 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I'm going to pause here for a second. Just kind of double check. So I have 8 electrons in this second energy level, and I know that energy level is full. Okay, up here, this little atom here had 1 energy level, and I know that this energy level is full with just 2. So some pattern I'm noticing here is this guy has a full energy of electrons, this guy has a full energy of electrons. And notice that they're together on the periodic table. Okay, they're kind of top and bottom there. Let's keep going here. My pen is being silly. So I'm gonna bring this down a little bit. So I know these inside levels are gonna be full. Come on, pen. Okay, so for this second level here, I know the inside levels have to be full first. This guy's going to have 11 total. So I got 1, 2, 3, 4, 5, 6, 7, 8. That middle level's full. Oh, I'm sorry. 9, 10 makes it full. 1, 2, 3, 4, 5, 6, 7, 8 in the middle. And so this is going to have 1 on the outside. Over here, I know the middle's going to be full. This is going to have 2 in the outside, 3 in the outside, 4 in the outside, 5 in the outside, because each time I just add one more, right? So this guy has 6 in the outside. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8 in the outside. And honestly, I don't really care about those inside ones anymore. The outside ones are the ones that are going to do all the cool things. Okay, so now my question is, do you see a pattern? Okay, so you guys had on a different worksheet, it talked about how elements that are in the same group, so the same row going up and down, have a lot of similar properties. So they act and look kind of the same. Well, check this out. This atom has 1 electron on the outside. This atom has 1 electron on the outside. If I'm able to scroll up a little bit here. This top guy, this hydrogen, has 1 on the outside. They all have 1 valence electron. 1 electron in the outside. Come on, pen. 1 valence E. Come on. Well, we all know it's valence electron. Apparently the pen is stuck. Okay, and that is also group 1 on the periodic table. Okay, so group 1 here all has 1 valence electron. Next door, here's my pen. This is group number 2, and these guys all have 2 valence electrons. See, 2 in the outside, 2 in the outside. Group 3 has 3, group 4 has 4, and so on and so forth, all the way over to here to group 8. I might be thinking, well, wait, Miss, on my periodic table, this isn't group 3, it says 13, 14, 15, 16, 17, 18. And that's true. Group 13 has 3, 14 has 4, 15 has 5. So in some older periodic tables, this will be called 3B, 4B, 5B. There's kind of been some different numbering systems through over the years. But this second letter here, or I'm sorry, the second number, tells you how many valence electrons are in that column. So drawing atoms just got a lot easier, okay? Now, there is another pattern on here. Okay, atoms that are on the same period, so periods go across, have something in common too. And this pattern might be easier to see because it was already written on your paper. In the interest of time, I'm not going to make you find the pattern, I will show it to you. Notice that this first row going across up here, period 1 has 1 energy level of electrons. Okay, now I'm going to change to a different pen color here. This row right here, period number 2 has 2 energy levels of electrons. Period 3 is going to have 3. So if you can count over and down, you can actually draw any atom now with no problems at all. Okay, so if I want to draw, let's say fluorine. Fluorine is atomic number 9 here. I can see that it is in 2 rows down, so period 2, and it is in group 17. So I know my fluorine atom needs 2 energy levels of electrons, and the outside is going to have 7. So that makes drawing atoms a lot easier. So go ahead and fill in some info on this sheet, and when you're ready, we will take a look at the next paper, and I'll show you how to simplify these pictures into something to make your life a lot easier, which is Lewis dot diagrams.